Hello guys, I hope everyone is doing well. So this is a quick run over what we've done last time since some of the students haven't showed up in class. So last time we done the first two topics. We started with module 2A, estimating demand curves for pricing. And we covered the first two, A1 and A2, the linear fit and the A2, the power fit, but we haven't finished A2. We were talking basically about in terms of optimization problem, we want to optimize, we want to make the best, to yield the best scenario. And that would be maximizing profit. So we need to maximize the profit, so we need to find the price. Remember, this module is about pricing. So it's about determining the price that satisfies the maximum or achieves the maximum profit. So we need to find the price that achieves the maximum profit. But before we do that, we need to find the demand curve. A demand curve, we are going to talk about it in a bit, is a relationship between the price in dollars and the units sold in numbers. So generic number. And it is a discrete number, 1, 2, 3, 4. You can't sell 2.5. As in marketing right now, we cannot express it in decimals. All right, so how about the profit? The objective is to maximize the profit. What is the formula for profit? The equation, for profit is price minus the unit cost. This would be the profit per unit multiplied by the number of units sold. All right, so now we know that the profit is price minus unit cost times the quantity sold. We talked a little bit about the formation of the demand curve. We said that if you took economic class and you've been plotting the price on the y-axis and the quantity or the demand on the x-axis, in the marketing style, we always plot the price on the x-axis and the quantity or the demand, which is a function of price on the y-axis. So mathematically, it does make sense that demand, which is a function of price, is plotted on the y-axis. All right, and we are changing the price. All right, so now let's talk about any linear line has a slope. And this slope in economics is called the elasticity of the demand, or the price elasticity of demand. So it is called price elasticity of demand. Price elasticity of demand is equal to the demand on the numerator and the price in the denominator. So we start with the price and end with the demand. After the equal sign, we start with the demand on the numerator and the price on the denominator. All right. I gave you examples of price elasticity for different products, different elasticity levels. And over here, as you may know, this is the law of demand. This is a representation of the law of demand. As you can see here, if you are plotting the price on the x-axis and the demand on the y-axis, as the price increases, we always say, even in regression analysis, we always express as this variable increases by 1 unit, then the y decreases or increases based on the sign of the coefficient. Over here, the sign of the coefficient of x is minus, so it decreases by 10. So as x increases by 1, always we say as increases by 1. We always express our relationship away from 0. We never say when x decreases by 1. We always traveling away or departing away from 0. As we depart away from 0, we are here increasing. So as the x increases by 1 unit, the y will decrease by 10 units. This means as the price increases by 1% in percentages, because the price elasticity here is in percentages. This is the units that we're talking about. So as the price increases by 1 unit, which is 1%, the demand will decrease by 10 units, or 10%, by 10 units actually. So here 500 minus 10, which is 500 minus 10 is 490. But when you want to figure out these points that led to this one, you will have to multiply 100 with 1 plus 0.01, which is increasing 1%. And over here it is multiplied by 1 minus 0.1, which is 10%. The elasticity. 1 minus 0.02, which is the elasticity. As the price increases by 1 unit, the demand will decrease by the amount of the elasticity by 2%. But over here in the equation, it will be easily translated into mere units. Do you see the difference? Over here, we say 500 multiplied by 1 minus 0.02. Over here, it's just basic mathematics. Any other point, you can find it very easily in the quiz in no time. All right, with the equation rather than with the elasticity. All right. So again, I'm going to mention this again. So if I give you the question in the quiz, it is up to you. You haven't been watching the videos. So if I give you another price point, if I tell you what would be the demand then at price 150, then the demand Y will be equal to minus 10 times 150 plus 1,500. So that would be the demand at price point 150. So you just need to plug in for 150 as price. All right, let's talk now about the power curve. With the power curve over here, the difference between any linear curve or any power curve in general is that the slope here is constant, which is a slope is the level of skewness, if I could say. So it is delta y over delta x, and the slope here is constant in the linear functions. So the slope is constant in linear functions. However, in power functions, as you can see here, the slope is changing. So it is not a constant slope, it is a changing slope. Usually in real life scenarios, our elasticity is not constant at different price points. The elasticity will change somehow over different price points. And this is why in economics you probably worked more with the power curve rather than the linear curve, because this is the reality. As a matter of fact, elasticity changes over different price points. All right, lovely people, let's begin. Now, as you can see here, the demand is a function of price, and it is equal to parameter A is a constant times price to the power of B, B being less than 0. If you don't want to write B less than 0, A greater than 0, you can just put it as A times B times P to the power of minus B, right? Similarly over here, you come and say the demand function of price, or the demand, is equal to A minus B times P, and you don't need to say any of that. But if you want to say it as a plus, A plus B times P, then you need to specify that B is less than 0, because the slope is always negative. This is a generalized form. So our demand function should be decreasing as we are moving away or departing away from 0, like that. But I couldn't find a nice representation other than this for what I'm trying to tell you about when do we use the linear curve and when do we use the power curve, right? All right. All right, lovely people, let's begin. So over here, we know A. We don't know A over here. We only know 2 points and the elasticity. This is why we plotted with the 2 points. Over here, we don't know how to find the second point, because the slope is not constant. I cannot use the elasticity and use it as a constant point at any point of price. So I cannot use the same elasticity over different points. So I need to find A. You see the Y? Over here we need to find A, while here we didn't care about finding A, because the elasticity or the slope is constant on different points of price. So I didn't need to find A. I have 2 points. I can find any point I want using the elasticity. Yeah, I can find the demand of any price point using the elasticity because the elasticity is constant across the whole curve. But over here, I can't use the same elasticity. This is an elasticity measure specific to that price point. But I can find A because A will be the same across all the curve. And this is what we are trying to do. So basically what you need to do is you need to set up your, we set it up in class, I believe. So please write express demand in terms of its function, not its point. I know that in the question we were given the point that at point price $100, the units sold were 500. Now, of course, we are always putting price, demand, elasticity, putting the price, plugging it in as 100, the demand, plugging it in here. You could say that it's 500, but I'd rather have you put it this way on the corner. P and D is 100 to 500, but demand, to find A, you need to express demand in a formula. So over here, I couldn't name this A, so I named it A parameter because I have so many sheets. This is the third attempt of recording this video, if you believe me or you don't believe me. Last time I recorded this video, this morning I recorded this video, and this is why I keep on watching if I have a recording instant in my file. I don't know what happens. I am not lucky. Ever since yesterday, so many crazy things happening. Actually, this last week, smashed my phone. So many other things happened to me, guys. So I'm sorry. I have so many sheets, and in all of them, I do have the solution. So please bear with me here. And over here, you just need to call it A parameter. Over here, we called it in class price. Over here, we call it demand. Over here, we call it elasticity. And you write the demand in terms of its function as A times the price to the power of elasticity. Okay? So this is very important. Bold it. Express demand in terms of its function, not its value or point value. Now, let's find out what A is. All right? So finding out what A is basically by going to the data and going to the what if analysis, goal seek. Over here, I'd rather start from the bottom up for now by changing cell, meaning I want to find A. Change A until you find the best value of A. Set cell, again from the top, set cell, set this cell that has a function, always should have a function, set it to a certain value, which is 500. We were given in the question that the value was 500, but the cell itself, E5 here, should include an equation, and as you can see, it keeps working. Now, if your value here was different than mine, if you were given 5E plus 0.6, it's the same, because E plus 0.6 is equivalent to 5 multiplied by 1 million, 1 with 6 zeros ahead of it. So E plus 0.1 means 10. E plus 0.2 is 100. E plus 0.6 is a million. I think you got it. So if your Mac or whatever computer system, and Excel in particular, is set up so that it will give scientific numbers, this is called scientific formulation. It will look like 5 point something E plus 0.6. Okay? So you will get the same answer. So now we have A. So we can plot and find any demand on any price point. So for example, I want the demand on price point 150. So that would be equal to, instead of price over here, I'm going to have this new price. So I was able to find the demand. If I increase the price by $50, the demand will drop, as you can see, from 500 to 200 to 222. So what I need to do here, instead of guessing certain values, I'm gonna plot the curve by specifying 10 points in such a way that If you want to know how I set this up, you just start with price. You just start with demand. You count 5 cells, 1, 2, 3, 4, 5. On the 5th one, I just highlighted it and I made it to be equal to this price point. And then I started building my way down and up by saying I want to decrease 10 points out of the 100. So I put it as here minus 10, this minus 10, this minus 10. The way I've done that is basically I just put this minus 10, copy and paste it. And look, it's awesome. You don't have to do it manually. And over here I just added plus 10 and then from the corner I dragged it down. Easy peasy, not time consuming. And over here, I just put the demand function exactly as I've done it here earlier. A times this way, the price is this one, this price to the elasticity. If you name these parameters, then they will be fixed. Their position will be fixed. If you don't name them, then please make sure that E3 has a dollar sign before the E and has a dollar sign before the 3. And likewise, for F5, it should have also a dollar sign before the F and a dollar sign before the 5. And we talked about this absolute referencing, so the cell will stay still. And then just to drag it, and then go like this, and go insert. And on the chart, use the scatter with a straight line and markers. I like this one. Not the line. Please use the scatter. And then you can have it as equal and then right click and add that trend line. In fact, we don't want to add the trend line per se. I am here specified as power, not exponential, not anything else. Because if you put it anything else, it won't be as precise. But put it as power, so it will overlay almost on it and display the equation. So if you take a look at the equation, you will find out that the equation is 5 million x to the power of minus 2. This worked nicely here, 5 million and all that, because the price is 100 here. Yeah? Anyway, please make sure that with your curve, you add a nice name to it, like power demand curve, and add these guys through where you can connect. Click on it, choose it, and add chart elements and add the axes here. So you can add the axes and call them price and demand. You can, of course, change the design if you want to any different other design of your liking as well. Okay, this is it for this video, and I will see you in the next video.